Okay, let's start with the basics of an exponential function, a graph. Once you know the basic shape of it, all the translations, the transformations that you've done in the past will be will follow suit from all the other shifts, the horizontal and vertical shift and the stretching and all that stuff. All right. So in the upper right, I just wrote what is an exponential function. So typically up until this point, our x has not been in the exponent, right? Our variable has not been the exponent. Now it is. And I also wrote a does not equal 1 because that would be boring. 1 to any exponent would always be 1. So we just have a horizontal line. So anything other than 1. I'm going to demonstrate y equals 2 to the x by choosing, we really don't need this many, but let's choose a handful of values here. And then I'll show you really, no matter what this base is here, there are common properties. So when I say base, I'm referring to the a value. Okay. So even if I made that a 5 to the x, the graph would be very similar to 2 to the x. Okay. So let's start with the positives though. Like anything to the 0 is 1. And that's why I was saying that even if it were a 5, this 0, if x is 0, y is 1, is still going to be true. 2 to the 1 is 2, 2 squared is 4, 2 to the third, 2 times 2 times 2 is 8. So I have 3 points that I could plot. 0, 1, and then I'll just go 1, 2, 3, 2, 3, 4, 5, 6, 7, 8. Yep. Okay. And then we're also doing negative, so we'll do that. Okay. 0, 1, 1, 2, 2, 4, 3, 8, and I'm purposely freehanding this and only chose these values because you'll see what happens rapidly in both directions, but it almost looks linear, right? I'm really tempted to just draw this line, but let's do the negative values. 2 to the negative 1. Remember, a negative exponent does not make it negative. In fact, 2 to the negative 1, that just means you do 1 over 2 to the 1. It makes it a fraction. Right? So we get 1/2. So in fact, once you know a couple of these values with a positive, all you do is you take the reciprocal. 2 to the negative 2 is 1/4. 2 to the negative 3 is 1/8, and so forth. So no matter what negative value I hit, I will never get a negative y, right? I could do x is negative 100. I still will not get y as a negative. It would be very small, but not negative. So let's graph these. 1/2 is somewhere here, right? 1/4 is closer to the 0. 1/8 is even closer. I can already not graph too accurate because I'm so close to 0. And what happens with these exponentials is they actually shoot up quite rapidly. Okay, and maybe I'm over exaggerating a little, but probably not. If I did 4, 2 to the 4th, I would be at 16. Right, so one more over, I'm way up here, I can't even hit the graph. So that is how quick exponential growth occurs. 2 to the 5th, right, I'm at 32. I'm way off the chart. So let's quickly just kind of do this in green. What if it were 5 to the x, like I said? So 5 to the 0 is still 1. That point remains here. But notice what happens is we get this vertical stretch. If a is larger, we're stretching it up. So if x were 1, we would have 5. Right? If x were 2, we'd have 25. 5 squared is 25. So this thing shoots up. Let's see, 5 is here. And then 25, I'm already way far up off the graph, right? Now if I go backwards, then I'd have 1/5, somewhere down here, 1/25. I'm already so close to 0, right? So think of a vertical stretch with this changing. It's just the steepness. It's how fast it's actually growing. All right. Now, 1/2, you think then, well, this doesn't grow as much, right? And that's the only, I guess, tricky part with these exponentials, is that a really is not the vertical stretch. It's if I were to multiply this by something, that would be the vertical stretch. So I wanted to show that it looks like that with the 5 and the 2, but we'll see here with this 1/2, it's not just like a vertical shrink. So choosing these same values, -3, -2, -1, 0, 1, 2, 3. We'll see what happens here. 0, we still get 1. Okay, that's the good thing with these exponentials, is 0, 1 is a common point until we start shifting it. Okay, let's do the positives. 1/2 to the 1 is 1/2. 1/2 squared would be 1/4. 1/2 to the third is 1/8. Notice these values are lined up with these values. And therefore, -1, like my guess would be, it'd be 2, 4, and 8. But let's verify that. 1/2 to the -1 is equivalent to doing the reciprocal 2/1 to the 1. Okay, if we have a fraction, we could do it in this manner, which is 2. So 1/2 to the -2 is like saying 2/1 squared, which is 4. Okay, so they do in fact coincide with the negatives here. 2, 4, 8 coincide with the positives here. So on a graph, 2, 3, 4, 5, 6, 7, 8, there's 8. Again, rough sketch, right? -1, 2 is here. -2, 4 is here. -3, 8 is here. 1 -1/2 somewhere there. 4th and 8th. So it looks like the graph of 2 to the x, but